How much of the code you shipped last month could you actually explain? Not roughly, not a general shape of it. Explain why it's built the way it is. What happens when it fails and which parts can you delete safely? For the lot of us, the honest answer to that question has changed this year. And I'm not here to make anybody feel bad about it because I'm in the same position on plenty of things I have shipped myself. I use these tools every day and I'm not giving them up. This isn't a video about AI being bad at coding, it's very good at coding. It's a video about what you are actually holding afterwards. Because there's a question sitting underneath all of this that I think we have not answered honestly. If you ship something that works and you couldn't rebuild it and you couldn't debug it at 2 am when it breaks, have you created a value? Or have you just built a time bomb with a longer fuse? Let me be fair first because there is a version of this that's genuinely good. A prototype to test whether an idea is worth pursuing, an internal tool 3 people use once a week, a script that runs and gets deleted. One shot, all of this. Being precious about craftsmanship that is just slow. And slow is its own kind of failure. But notice what all of them have in common. They are supposed to die. The prototype gets thrown away once you learn the thing. The internal tool gets replaced when it stops being enough. The script gets deleted. And here's the problem. They never die on schedule because it works and that's the trap. It demos well, somebody sees it, and now the prototype is in front of a customer. The internal tool has 40 users and holds real data. Nobody sat down and decided to promote it to production. It just quietly stopped being temporary while nobody was looking. So let's ask the value question properly. Value for whom? For you? Only if you learned something. And if you can't read the thing you shipped, you didn't learn anything. You have an artifact, not a skill. Next time the same task appears, you are in the exactly same position asking the same machine, hoping for the same luck. For your users, value right up until the moment it breaks. And then it isn't just zero, it's negative. Because now it's their data and their trust paying for it. And for whoever inherits it, it is negative from day one. Let me explain why that one is worse than it sounds. The hardest problem in this industry has always been the person who built it leaving. A new engineer inherits a code base they have never seen, no context, half the reasoning lived in this somebody else's head and walked out of the door with them. So they are scared to touch anything they built around the old code instead of fixing it. And every team ends up with the file nobody will open. And one-shotted app is that problem on day one, except worse, because at least when an engineer leaves, somebody understood it. Here, nobody ever did. You've shipped a legacy codebase with no author to ask, and that's what makes this different from an ordinary technical debt, which people get wrong constantly. Normal debt is a decision. You understood the trade-off, chose speed deliberately, and you can pay it back because you know exactly what you borrowed. This isn't a debt, it's a liability you don't know you're carrying at an interest rate you can't see with no record of the loan itself. And the fuse is always the same thing. It's the first requirement that wasn't in the original prompt, the first real traffic, the first dependency that has been updated, the first security probe, the first time somebody asks for a change and you open the file and you realize you have no idea which part is load bearing. I made a separate video about somebody using AI assistant to probe my servers for leaked credential. Every single thing that attacker went on for is a mistake one-shotted app makes by default. Secret sitting at public path, config exposed, nobody watching. And AI will happily generate an application with every one of those holes in it and never mention a single one because you didn't ask? The honest answer on speed is that nobody agrees. Google ran a controlled trial and found engineers about 21% faster. METR ran one and found experienced developers 19% slower, while every one of them believed they were faster. The other side is not in dispute. Veracode tested over 100 models across 80 coding tasks. 45% of the code they wrote shipped with the vulnerability from the OWASP top 10. You cannot even measure whether it made you faster, you can measure what it left behind. So no, it isn't automatically a bomb. It becomes one the moment it outlives the reason you built it that way. And almost nothing gets deleted on schedule, which raises the obvious follow-up. If the code is nearly free to produce, what exactly are we being paid for? A study this year looked at 9,000 pull requests opened by AI agents. 3/4 of them were merged with no changes at all, not reviewed and approved, merged unmodified. That is the whole problem in one number. The code is not the part you are being paid for, reading it is. You need systems knowledge to see that the generated code works but will fail over at scale. You need stack knowledge to see that it's technically valid but fights the framework. You need security knowledge to see that it's functional and quietly exposes something. None of it is prompting, all of it is engineering. And I want to tell you about conversation that sharpened this for me. I was talking to a senior engineer at Uber. I'd like to work somewhere like that eventually, so I was doing what you do in those situations. Listening to how he thinks, how he explains things, what he actually pays attention to when he talks about technology. At some point I asked what they look for in a candidate. He answered it in a one sentence. We don't care about the tech stack you know. Anyone can learn a language. We look for someone who understands systems and can scale them. Now that sounds dismissive of technical depth, and it absolutely isn't. So let me draw the distinction because it's the most useful one in this whole video. Knowing a stack is knowing that your ORM generates this particular query, that your runtimes handles the concurrency that way. Knowing that your framework renders at this moment, not at that one. Knowing systems is knowing what happens when the thing you build meets 10,000 people at once and where it queues, where it retries, and whether those retries makes the problem worse. What falls over and what falls over only because the first thing fell over. The stack is where you build your intuition, but the intuition is a part that transfers. That's how he can say both things at once. He isn't saying stack knowledge is worthless. He's saying it isn't the currency. Deep knowledge of one stack is evidence that you can think in systems. Shallow familiarity with 10 is an evidence of nothing. And I keep coming back to the conversation because of where it lands in the AI world. AI made code cheap, genuinely dramatically cheap. It did not make architecture cheap. You can generate a function in seconds. You cannot regenerate the decision to shard your database that way. You cannot undraw a service boundary you got wrong 18 months ago. You cannot easily walk back a data model that half your company now depends on. Code becomes reversible in a way it never was before. Architecture was never reversible. It still isn't. So when the cost of one thing collapses and the cost of other doesn't move at all, the relative value of the expensive goes up. That's not optimistic, that's arithmetic. And system design is the thing these models are genuinely worst at for a specific reason. They can produce a plausible architecture. They have read every architecture ever published. What they cannot do is make trade-off against constraint they have never seen, which includes your traffic shape, your team size, and who on the team can actually maintain the thing you are proposing, your budget, your compliance requirement, the 3-year-old service nobody wants to touch, the fact that you are the one carrying the pager for this. There is no correct answer in system design. There is only appropriate ones. And the appropriate is a function of your situation which the model has never seen or has ever been in. Which brings me to the last thing, and I think it's the most underrated advantage available right now, and it is domain knowledge. Lightcast went through over a billion job posting. More than half the roles now asking for AI skills are outside software entirely. The premium is not going to people who know AI. It's going to people who know AI and a field. A generalist who knows how to prompt will always be outperformed by a domain expert who knows how to prompt. Because the model knows how to write a payment integration, it does not know that in your industry a refund has to stay reversible for 180 days. It knows how to write a form. It doesn't know which of these fields your regulatory says you're not allowed to store at all. The model has read everything ever written about your field. It has never once sat in a meeting where somebody explained why the obvious solution doesn't work here. The gap between what's written down and what's actually true in your industry is not closing, and it's where all the leverage is. So back to where we started. Is AI generated code a ticking time bomb? Only if you don't understand it, and only if it outlives the reason you built it fast, which almost everything does. The fix isn't to stop using these tools. I'm not going to, and neither should you. The fix is to stay the person who can read what came out. Because the code got cheap, the architecture didn't, and the judgment about which is which was never for sale in the first place.